This webinar is going to be about the digital configuration thread, and very basically I'm going to start by explaining how we define the configuration thread, why it's important, and then I will spend the majority of the time to go into 6 sort of use cases where we see this configuration thread to be used and being relevant. Please ask questions as we go along. I might pick them up as we go. Otherwise, we'll have a bit of time in the end. And if we don't manage to answer them there, we will collect them and send you a written answer afterwards. So what is the digital thread? You can find some definitions online. This definition here is from Gartner. The way they define a digital thread is fairly broad, I would say, and fairly vague, you could also say. They say it's a framework that enables connection, orchestration, and presentation of data for multiple factors influencing a product and/or process and their evolutions over the life cycle of the products and data. So what we can see from this is that they define this as something that governs a fairly wide set of artifacts. It can be a process, it can be a product, it relates to its life cycle. I think that's a key word here. But it doesn't say that much about how to achieve this and what systems are really in play. I also picked up another definition. This one comes from PDC, as they are defining their digital thread. And in this definition, you will find that they are more precise in some ways. They talk about how it's relevant data that defines a product throughout its life cycle. Again, it's about the life cycle. It talks about breaking down silos, and I think that's one of the key elements of the thread, that it really is about connecting data from different systems over its lifetime. And it also talks about how you get access and use data that otherwise is quite inaccessible. And of course, that's back to the silos. So when we talk about a digital configuration thread, of course, that is because in Configit, we deal with configurable products. And therefore, the thread in our context is quite specific, you could say, to how that product and how that configurable product evolves over time. So we deal with configurable products. It could be a car, it could be a complex machine, it could be a factory. What's common for these products is that they are configurable, and that means that there's a set of features or options or characteristics, whatever you call them, that define the choices that a customer might choose to get. And then there are some rules that govern how these choices affect each other. And in this context, a configuration is basically what has been selected for these features and to define this particular instance that you're looking at. There is a bit of confusion, in particular when you talk to engineers and product design people, because the word configuration tends to be used in other contexts and in other meanings. And in particular, there's a domain called configuration management. And in that context, the word configuration really referred to more like a version of some artifacts. But what I'm talking about here, when we talk about a configuration, is select specific values for each of the features of the model, of the product that you're configuring. Some people have called that a feature string. And we use sometimes this sort of DNA type symbol to illustrate it. It's because when you have this set of choices of values to the features, if you have that, you can derive a lot of other information. So, for example, you can derive the bill of material, or you can derive the specific CAD drawing for that particular configuration, or you can derive or the prices, the price calculation that makes up the price and the costing of that particular product. So in that sense, the configuration is sort of the center, and from there you can derive a bunch of other types of information. So in this context of configurable products, we look at the thread in terms of, you could say, two different aspects. One aspect is you start out by defining all the possible ways you can configure a product. So that's sort of how that's what we use what's called the product model for. That's like what defines the set of valid configurations. That's the design space, but fairly early in the life cycle of a given product, that choice, that space of all the choices gets fixed. Typically, if it's a configure to order process, it gets fixed when you start interacting with a customer and that customer selects values for the features. Then he establishes that configuration at that time. If you have an engineer to order process, it might be that you even have that choice being made much sooner in the design phase. But at some point you fix and get from the possible available configurations down to the specific instance. And then you start a journey of how you manage that instance over the life cycle of that particular product. So I tried to illustrate that with our CLM drawing there on the right. You could say that in the early phases of a product definition, you talk about where you do design validation, you do the actual design of the product, and in there you need to have configurations that can help you to do that validation. At some point you will get to a customer. He might go to a website, he might be configuring the product there. That may lead to a quote that gets created. That quote may have a life cycle as well. So at some point you update that configuration to a new one, and that becomes maybe the one that gets ordered. When it gets ordered, at some point it gets sent to manufacturing. They may adapt the configuration based on the needs. It could be that depending on how the product, where it's going to be shipped, it might be different ways you want to manufacture it. Then it gets delivered. The product gets deployed. As part of that deployment, there is also a configuration process where you update the product configuration, because you might, for example, set certain parameters in the software. Later, it will be, well, I guess that's where you commission it, and then later you might service it, you might update it, you might change it. That will also affect the configuration of the product. And finally, you will decommission and replace it. So in all of these phases of the product's lifecycle, there will be a configuration behind the scenes that specifies how that product has been configured, and that configuration will evolve through these different phases. And that's why we talk about the configuration thread. It's what I've written here in the left. It's a configuration that has references to the previous versions of the configuration. So there's this aspect of you can trace back from one configuration to the previous one, and so forth, all the way back to the original one. But it also has a reference to the data that was used to create the configuration. And I think that's quite important, because nothing is standing still. You might have one set of rules in place when you ordered the product, but that set of rules will maybe have changed also when you then get to the manufacturing and when you get to the delivery. So you also need to manage how these configurations, even if they stay the same, how they refer back to this rule set that also goes through an evolution. We are bringing out the first version of what we call Ace Thread, and this is in Configit the first time we expose through open APIs a set of services that allows you to create these threads. It's a little bit surprising maybe that we have existed for 25 years and still haven't had this before until now, but with our cloud instances and SaaS services, this is becoming obvious that this is something that there's a need for. So we are bringing out the first version of this in our release here later this month, and this is of course to enable supporting customers that would like to do this. Some of the reasons why we have decided to do that, I think we have identified 6 key benefits for customers, 6 reasons why this thread is important. And I have listed them here just as a headline, and then I will go into each one of them in the following slides. So one reason has to do with service and how you can service a product. How do you know how a certain product has been configured and how that will help you to service it much more efficiently? We have looked at how you can upgrade existing systems and add new capabilities or extended capabilities to existing already sold and commissioned products. You can use the thread to optimize. You could say basically look at the engineering side of things and how you can optimize that. You can use it to improve the collaboration, and thereby you also improve the quality. You can use it to find issues earlier, and you can finally use it to support being regulatory compliant. So I will go through this now, try to give a few examples of how this has been used in cases that we have been dealing with. No questions so far. So when you deal with configurable products, one of the challenges is that you deal with a lot of possible combinations. I put a number here, 10 to the 21 number of different valid Land Rover, particular Land Rover sports variants. This is a number that we calculated some years ago, but this is just to illustrate that you're dealing with billions of combinations. 10 to the 21 is a very, very, very large number. And of course, there's no way you can test each one of them explicitly. You cannot just list them out and say, now we do a validation and verification phase of each one of them. There's absolutely no way you can do that. So what companies do when they have to build these products and get them out there and get them validated, basically take them through the V model as I illustrated here at the bottom. What they do is that they create some carefully selected configurations, and they use those as reference points. It could be like you create a few base configurations, then you create some of the typical ones in between, and then you also create some of the very fully loaded cars if it was a car. And then you carefully manage those configurations through the design process, and you take your configurable products through the validation phases for those maybe 10 or 100 selected configurations. And of course, when you do that, you need to have a place to store these. You have a place to make sure that they always are valid, that they are kept aligned with the rules that typically also will change in the same time frame. So you have to have a way to manage these configurations, and having a configuration store or an Ace Thread database with those is a natural way to basically avoid the cost of misconfigurations and miscommunications. So this is in the engineering space. You can also imagine that you have a bunch of configurations that you have saved and that you are happy with. It could be previous orders, it could be your existing order bank, but you have this set of configurations that you are quite sure is or were correct at the time where they were created. And now you do some changes to the logical model. You change a rule, you change whatever, and how do you then validate that that updated model is still correct? And what we've seen many of our customers do is that they take this order bank, they take this database of thousands of existing configurations that they expect to be valid, and they basically run those through with the updated rule model and validate that they still are valid. If there's one that's not valid, then two things can be the case. Either you have made a mistake and created an invalid rule set, or it could, of course, be that the world has changed. Suddenly, a certain combination is no longer available, and you would have to deal with that with those orders that might have violated that. So the point here is that you can use the Ace Thread. You can use this collection of all configurations or subset of them to ensure the quality of the models that you bring out. We have also seen configurations being used to optimize, and I think this is one of the more sort of exotic uses. We worked with Audi some time ago, and basically what we looked at there was to look at a number of existing already sold configurations of their vehicles. So we had about 1 million configurations of a particular model, and what we looked at was what the group at Audi was looking at that we worked with. They looked at how you could optimize a particular part of the vehicle. So here you see on the left, it's the controls that sits right behind the steering wheel, and they have different capabilities. They have different features that they sell. And now this happens to be in German, but it's like with or without lane assist and adaptive cruise control and heated steering wheel and that type of thing. And these different features that the customers could choose or not choose, they basically affected this particular part. What you can do is that based on sold configurations, you can do a statistical analysis where you go through and what you cannot read the diagram on the right here, but basically this is all the different choices with or without steering, or a heated steering wheel, with or without adaptive cruise control, and so on. These are the different options, and then they will end up in a node there on the right, and you can, based on statistics, you can then determine the probability of a certain combination to be selected. Now, by combining this with the bill of material, you can then identify those variants that are very likely or very unlikely. And in this case, they realized that there were 96 different variants of this particular part. And when they looked into it, they could see that, for example, only 7 of them were used in 80% of all orders. So you can do all kinds of analysis here. You can start to, there might be good reasons for why certain combinations are there. But if you want to get rid of some of them and save cost that way, a simple way of doing it would be to start bundling some of these features together. So you would maybe do a high-end, medium, and low-end spec. So you only have 3 different variants. And that's very easy to achieve by adding a few rules in your configuration engine. And it would only allow those 3. We have also seen that the availability of the configuration can be used to service a product. So you can imagine that you have to go out and service a very complex machine, and you need to have the right tools available. You have to have the right parts available. You might have to have the right software available. So knowing exactly what has been put out there is a key sort of enabler to allow you to get it right. And for some of these manufacturing companies, having a downtime is really, really critical. If that downtime, imagine a service technician's come out, he starts replacing some parts, he starts working on the machine, and then when he brings it up, there's an issue. And that might mean that the machine is down for days or weeks, and that is super critical. So getting this right is very important to have basically a successful upgrade and a happy customer. We also see configuration models being used when you wanted to improve or enhance a existing product. So the situation here is that you have a product that maybe was sold some years ago, imagine a tractor like the one shown here. And now the farmer who owns this tractor would like to have an upgrade to this machine. So the question is, how do I enhance it with new capabilities? What will fit today on this product that was sold some years ago? And in order to answer that question, you need to know, first of all, what was sold originally. That's where the configuration thread comes in. But then you also need to know, how can I upgrade that older configuration? Because some of the features that were available back then, they will no longer be available, of course. So you need to have a configuration model that helps you to do this upgrade. It will have to know about the old features as well as the new one. And we've seen a number of our customers who do this. They develop these configuration models with this purpose alone. And that actually also allows them to maybe add accessories to existing product. Now I've shown a John Deere tractor, but it could be that the John Deere tractor could be extended with products that came from a competitor to John Deere. And that is actually quite possible, but you would then have to know what was the capabilities of the product that you have to start with. What types of connectors, what types of software, what types of capabilities does it have when it was built. And now this is a tractor, but we will all see a similar challenge also with our cars. How can we extend the functionality, typically in software, based on how that car was configured when you bought it? That will have an effect on what sensors are on there, and thereby also how can I extend that to support new capabilities. So the last usage I wanted to present today is about the Ace Thread, is about regulatory compliance. We see an increase in the rules that gets put out there, and this is of course mostly due to the environmental constraints or sustainability initiatives that takes place. The graph there on the right shows that EU has more than anybody else, but the rest of the world is following along. And having and you have to have a need. Companies that do manufacturing will have to comply with these rules, and they come in at an increasing speed. One example of that is that soon we will have the digital product passport. This is an EU initiative. It basically specifies that you, for any product, basically any product, you can look up the full chain of what's in that product, what types of materials are in it, and this goes not just to the supplier, but also the sub-suppliers of the manufacturer. Of course, this is to help us understand the product's properties in terms of sustainability, environmental, and recyclability. Now, the challenge here is that for configurable products, unlike standard products, there's not just one passport. There is an individual passport for every instance of the product. So suddenly you have to manage not just one part number and understand all the details. You can probably do that manually, collect all the information to one product and expose that. But if it's a configurable product, all these different aspects that goes into a digital product passport will depend on how you have configured the product. So in order to expose the passport to your customers, you must know for each instance how it was configured, and based on that, drive the information and pull out the information about whether it's a CO2 footprint or whatever it might be. Pull that out from a database based on the configuration string. So that was some cases where we see a use of the Ace Thread. As I said, we are now releasing the first version of this, coming very soon. in our SaaS environments. Those customers who will be upgrading to A7 will have this available immediately. And the benefits, of course, are some of the things listed here on the right, that you can save the configurations, you can retrieve them, and you can associate metadata to those configurations to help you manage them. So metadata can be things that identify a certain configuration as sold, as manufactured, as delivered, and so on. So we're very excited about this. This is one of several key new features that we bring out. We have also our Ace configurator and our Ace lab and other things that I'm sure other people will talk about. So that's basically what I wanted to talk about today. The short story, I think, is that we see the Ace Thread as a key enabler to connect these data across the different silos, across the different data sources. And we believe that having a centralized place to store these configurations will really allow us and enable us to do interesting things, to optimize and analyze what's being quoted, what's being sold out there. So with that, I basically want to hear if there are any questions out there.
Yeah, we do have a few questions. Let me start with this one. Other companies, PLM specifically, also discuss about the digital thread and digital twin. Can these stored configurations be related to the digital twin or used for it?
Yeah, so they are closely related, and the digital twin, the way I understand it, is that you have sort of a simulation model of a physical instance, and based on data that's being collected out in the physical instance, you can simulate that, and you can, for example, do predictive maintenance based on that. But in order for that to work, of course, you must have a alignment between, you must have a virtual version of what's out there. And as I said, based on the configuration, you can derive many types of information, and one of the types of information to derive would be exactly this, the virtual model of what's out there. Of course, in order for that to work, you must make sure that the virtual version, the simulated version, is being kept up to date with what's happening now in the real world. So if there happens to be a service technician who goes out and does something to the machine in the field, you need to make sure that that information, that updated configuration, is then also being reflected back in the virtual instance. But I see the Ace Thread as exactly that link that allows you to keep those two in sync.
Great. Let me see here. I have another question about servicing. The configuration data is only one piece of the puzzle. For servicing purposes, you also need BOM data. How would I ensure that this data is saved in a way I can find it again, and how would I version it and maintain it?
Yeah, so I mean, versioning and maintaining the configuration over time, that's exactly what our Ace Thread is doing. But of course, you also need the BOM data. And just like the configuration models will evolve over time, so will the BOM data. So you will have to maintain that in typically the PLM system, and you would have to have a way to reference the version from the configuration to the version of the bill of material. But if you do that, I don't see any issue in being able to derive the BOM based on the configuration information that you have at any point in time.
Okay, I think we have time for one more. Let me take this one about ETO to CTO. How would a database of my configurations help me in transitioning away from engineer to order towards a more configure to order?
Yeah, so this is of course a big challenge for engineer to order companies. How do they get started with configurable products? And what some companies do is actually start by introducing a feature language, even though they keep an engineer to order process, they start mapping the requirements to features and just use that as a mechanism to capture and trace the, you could say, the individual solutions on a feature level. And I think that's a fairly clever way of getting started, because you start identifying these key features that eventually will be the ones that you use in your configuration models. So you can certainly start by just having a thread, just having a configuration store, and having a way to manage for each solution you do for each specific customer. You keep around that these were the feature content of that solution. That will enable you to, for example, identify prior solutions that you've done to other customers, because it's much easier to search on feature codes than it is on trying to find the individual parts, for example, or subsystems. So it's a good way to get started, I would say, on that conversion towards more CTO.
Great. Let's just do one more. I think we have a couple minutes left. A big practical problem is to keep data in sync across the many systems we use. Would you be able to use a service like Ace Thread to actually maintain your data across different platforms?
I mean, yeah. There's no doubt that keeping data aligned is a big challenge. In particular, because data sits in different systems and you have to somehow communicate across them. We believe that the Ace Thread could be an enabler to do that. We have, you can imagine, ways to notify subsystems or other systems about updates. We also see that that you can use the configurations to make sure that other systems, for example, have been updated. Sometimes it's as simple that, say, a new feature gets introduced in the PLM system. You start exposing that data, maybe in sales channel, a website. You start see configurations being created, but are you then sure that you have all the pricing data to know whether the manufacturing system have been updated? I'm not sure the thread is sort of the key way of doing this, but it certainly could be a communication sort of mechanism between the systems.